Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve January 2021 question number 10 International A-Level Edexcel Pure Mathematics 4 P4. The topic is modeling with differential equations. So part A says that write 1 over h minus 5 times h plus 3 in partial fractions form. So as we know that this is a proper fraction because numerator's degree is less than the denominator's degree. The numerator is a constant term, the denominator is quadratic, but it is expressed as two linear factors, as a product of two linear factors. And as we can see that the denominator is of type in which there are linear factors. So this will be expressed as a upon h minus 5 plus b upon h plus 3. Okay, so now the step what we do over here is that multiply this complete denominator on both sides. So this will be 1 is equals to, and since this is basically an identity, I mean we will solve it like an equation, but this is an identity. Left hand side is equals to right hand side. Okay, so we are expressing this fraction, this rational fraction, as a sum of its partial fractions. So conceptually speaking, this is an identity. Okay, so 1 is equals to a multiplied by h plus 3 plus b multiplied by h minus 5. So first of all, what we can do over here is that we can make this a 0 and find out the value of b, and for that purpose we will substitute h is equals to minus 3. So 1 is equals to a times 0 plus b times minus 3 minus 5. Therefore 1 is equals to minus 8b, and therefore b equals minus 1 over 8. As simple as that. And then what we will make this b term 0 in order to find the value of a, and for that purpose we will substitute h equals 5. So if we put h equals 5 over here, so what's going to happen? 1 is equals to a times 5 plus 3 plus b times 0. So 8a is equals to 1, therefore a is equals to 1 over 8. So we need to express it in the partial fractions form. If you just leave the answer like that, the value of a is this and the value of b is this, you won't be getting full marks. You need to express it in the partial fractions form. Okay, the screen is little bit slow. Okay, so a upon h minus 5, so this is 1 over 8 divided by h minus 5 minus 1 over 8 divided by h plus 3. Alternatively, what we can write our final answer like this: 1 upon 8h minus 40, because this 8 is coming in the denominator. So 1 upon 8h minus 40 minus 1 upon 8h plus 24. Okay, this is supposed to be our answer to part A. Let's move on to the next part. Now actually the story begins that the depth of water in a storage tank is being monitored. The depth of water in the tank, h meters, is modeled by the differential equation dh over dt is equals to minus times h minus 5 times h plus 3 over 40, where t is the time in days from when the monitoring began. So as we can see that the change in h meters with respect to t, this function dh over dt is having a minus sign over here. So as you know, the days are being gone since the monitoring has started, so the water, the depth of the water in h meters is now declining. That's why we have a negative sign over here. Okay, so as you know, as the number of days will pass after the monitoring was started, the depth of the water in the tank will be reduced, because there is no inflow of the water, only water is going out of the tank. Where t is a time in days from when the monitoring began, given that the initial depth of the water when you did not started the monitoring. So this means when t is equal to 0, the depth of the water in the tank was 13 meter. T is equal to 0, so h is equals to 13. Part B says that solve the differential equation to show that h is equals to 10 plus 3 times e raised to the power minus 0.2 t upon 2 minus e raised to the power minus 0.2 t. Okay, and this is worth 7 marks. So as we know the fact that dh over dt is equals to minus times h minus 5 times h plus 3 over 40. First of all, what we are going to do, we are going to separate the variables over there. So I can say that dh over h minus 5 multiplied by h plus 3, this is equals to minus dt over 40. So what we have done, we have separated the variables. So this means that 1 upon h minus 5 times h plus 3 will be integrated with respect to h, and minus 1 over 40 will be integrated with respect to t. Now what we need to do, we need to integrate both sides. Okay. And after the integration, you will add c on any of the two sides. Either you add c on the left side or you add the c, the constant term, on the right hand side. But the usual practice is to add c on the right hand side of the equation, okay, after the integration. So as we know the fact that we have expressed 1 upon h minus 5 times h plus 3 in partial fractions in part A. And what we have obtained, 1 upon 8h minus 40. So in place of this whole fraction, what I'm going to write, 1 upon 8h minus 40 and then minus 1 upon 8h plus 24. Okay. We need to integrate this with respect to h, and on the right hand side of the equation, minus 1 over 40 will be integrated. Minus 1 over 40 will be integrated with respect to t. As simple as that. So when you integrate 1 upon 8h minus 40, this is basically integration as the reverse process of differentiating ln x. In this case, the variable is not x, so I would say that integration as a reverse process of differentiating ln, and that I mean the term in the ln function is in terms of h. Okay, so the variable in this case is h, not x. Okay, so when we integrate this 1 upon 8h minus 40, this will be ln modulus of 8h minus 40, and then divided by the derivative of 8h minus 40. Okay, and then you have a minus sign over here, and when 1 upon 8h plus 24 will be integrated with respect to h, so this will be ln modulus of 8h plus 24, and then completely divided by the derivative of 8h plus 24, which is 8. And on the right hand side of the equation, this is just a simple algebraic integration. Minus 1 over 40, when this will be integrated with respect to t, this will become minus 1 over 40 multiplied by t. And then you add c on any of the two sides. Either you add c on the right hand side, as I've done, or you add c on the left hand side. You don't need to add c on both sides because that c will be cancelled out then. Okay. And as far as the concepts of integrating as a reverse process of differentiating ln functions, as far as this concept is concerned, let me just give you a short overview on this. As we know the matter of fact that when y equals ln fx, so the dy over dx is supposed to be 1 upon fx multiplied by f dash x. And in this case, I'm just simply referring to the form of ln ax plus b. So as we know the fact that when y is equals to ln ax plus b, so dy over dx dy over dx is supposed to be 1 upon ax plus b and then multiplied by the derivative of ax plus b, which is supposed to be a. Which means that when y is equals to ln ax plus b, so dy over dx is supposed to be a upon ax plus b. All right. So this means that since integration is a reverse process of differentiation, we can say that when you integrate a over ax plus b with respect to x, you will exactly get ln ax plus b, and then obviously plus c, as we are dealing with the definite integral over here. And the reason for keeping this modular sign is that the terms in the ln function are supposed to be positive only. That's why. Okay. So this definitely implies the fact that if you adjust this constant term a, if you want to integrate 1 upon ax plus b with respect to x, meaning you need to cancel this a out. So you will multiply the left hand side of this equation with 1 over a. So obviously you are going to also multiply the right hand side of the equation with 1 over a, and therefore we can say that the integration of 1 upon ax plus b with respect to x is supposed to be 1 over a multiplied by ln ax plus b, and then obviously plus c. As simple as that. These are the concepts over here. So let's come back to the question which we are solving. The screen is, performing a little bit slow. It's just a delay of a few seconds between what I'm saying and what is actually shown on the screen. Okay. So far we have achieved this thing. As we know the fact that when, the initial depth of the water in the tank was 13 meters, which means that when t is equals to 0, h equals 13. Okay, so ln, I'm just going to put this condition in order to find the value of this c, this constant term. So ln 8 times 13, then minus 40 upon 8 minus ln 8 times 13 plus 24 divided by 8. This is equals to minus 1 over 40 multiplied by 0. So this will be equal to 0 and then plus c. Okay, as t is equal to 0 in this case. So 8 times 13 and then minus 40, this is 64. So ln 64 divided by 8, ln 64 completely divided by 8. Okay, minus ln 8 times 13 and then plus 24, this is supposed to be 128. So minus ln 128 and then divided by 8. And this is equals to c. So as we can see that 1 over 8 is a common term over here. Okay, so I'm going to just express this constant term c as a single ln function, ln term that you can say. So c equals taking 1 over 8 as common multiplied by ln 64 minus ln 128. Now I can use the quotient rule of log. Okay, so c equals 1 over 8 multiplied by ln 64 over 128, and 64 over 128, this is supposed to be half. So c equals 1 over 8 multiplied by ln half. Or what we can do, alternatively we can say that ln half is exactly equals to minus ln 2. I've explained this thing in my earlier video as well, the video in which there were the 3 questions of the same exam paper of integration. So ln 1 over a is exactly equals to minus ln a. So alternatively, what I can do over here is write this c like this, that 1 over 8 multiplied by minus ln 2. So therefore c is equals to minus 1 over 8 multiplied by ln 2. We can write it in both ways. Now what we need to do, we need to make h the subject over here so that we can achieve this thing over here. Okay, so I'm just going to take it on the next page. What we have achieved so far, ln. Okay, what we can do over here is we can take 1 over 8 as a constant term now. 1 over 8 as a common term multiplied by ln 8h minus 40 minus ln 8h plus 24, and this is equals to minus 1 over 40. Okay, what is the decimal form of minus 1 over 40? This is minus 0.025. So I'm going to write minus 0.025 t and then plus c, and in place of c I can write minus 1 over 8 ln 2, minus 1 over 8 ln 2. All right, so what I can do over here is that take this minus 1 over 8 ln 2 on the other side. So 1 over 8 multiplied by ln, and in place of 8 I mean ln 8h minus 40 minus ln 8h plus 24, we can use the quotient tool over here, the quotient law of logs. So ln 8h minus 40 divided by 8h plus 24, and then we have plus 1 over 8 times ln 2, and this is equals to minus 0.025 t. All right, so now what we can say that we have taken, I mean, as we can see that 1 over 8 is also a constant term over here. So now we can say that 1 over 8 multiplied by ln 8h minus 40, ln 8h minus 40 divided by 8h plus 24. I mean ln, the term completely is 8h minus 40 over 8h plus 24, and plus ln 2, as 1 over 8 is taken common over here, and then this is equals to minus 0.025 t. And now we can use the product law of logs. So this 2 will be multiplied over here. So 1 over 8 times ln, when 2 is multiplied, so this gives us 16h minus 80, and then divided by 8h plus 24, and this is equals to minus 0.025 t. So far we have achieved this thing. Now what we can do, we can adjust this constant term 1 over 8. Okay, and we can rewrite our equation like this, that ln 16h minus 80 divided by 8h plus 24, this is equals to 8 multiplied by minus 0.025 t. So 8 multiplied by minus 0.025, this is supposed to be minus 0.2, so minus 0.2 t. Now what we are going to do, make 16h minus 80 over 8h plus 24 the subject of the equation, and we need to remove this log and convert this into an exponential form. So as you know that ln is basically the log with the base e. So when 16h minus 80 divided by 8h plus 24 is made the subject of the equation, so this will be equals to e raised to the power minus 0.2 t. Okay, now 16h minus 80 is equals to 8, you can say that 8h multiplied by e raised to the power minus 0.2 t, and then plus 24 multiplied by e raised to the power minus 0.2 t. So far we have achieved this thing. Now what we need to do, we need to make h the subject of the equation over here. So the terms which are related to h will be on one side, and the terms which are not related to h will be on the other side. So I'm just going to do my working over here on the top. So 16h minus 8h times e raised to the power minus 0.2 t. This will be equals to 24 e raised to the power minus 0.2 t plus 80 plus 80. And now when we take h as common, we are left with 16 minus 8 times e raised to the power minus 0.2 t, and this will be equals to 24 e raised to the power minus 0.2 t, and then plus 80. And when we make h the subject of the equation, I'm doing working on the bottom with this blue pen now. if we make h the subject of the equation, so this will be equals to 24 times e raised to the power minus 0.2t plus 80 divided by 16 minus 8 e raised to the power minus 0.2t. But our requirement is to completely express in this form. That is to simplify the fraction as well. So let me just take a screenshot of this thing for the next page so that we can compare it easily. Allahumma jannah min an-nar. Okay, we need to express it into exact form which is required. Just wait for a second. I don't know why this time the screen is performing a little bit slow. Everything else is working perfectly fine though. So as we can see that, in the denominator we are left with 2 minus e raised to the power minus 0.2t. So in the denominator, obviously we need to take 8 as common, and over here what we need to do, this in place of 24 e raised to the power minus 0.2t, you have 3 multiplied by e raised to the power minus 0.2t. So 24 over 3 is supposed to be 8. We need to take 8 as common. All right, as simple as that. We don't need to do any calculations for this. So h equals taking 8 common in the numerator multiplied by 3 e raised to the power minus 0.2t and then plus 10. Let me write it neatly. And then in the denominator, we need to take 8 as common multiplied by 2 minus e raised to the power minus 0.2t. So 8 and 8 are cancelled out, and therefore we finally leave our answer like this, as which is required. H is equal to 10 plus 3 e raised to the power minus 0.2t. Let me make some space over here and write it with this green pen. H equals 10 plus 3 e raised to the power minus 0.2t divided by 2 minus e raised to the power minus 0.2t. Here you go. This is supposed to be our final answer, and this complete working is for 7 marks. Okay, combined with this working as well. Then part C says that hence find the time taken for the depth of water in the tank to fall to 8 meters. So in place of h, we will take 8 and we will find the corresponding value of t. As we know that h equals what? 10 plus 3 e raised to the power minus 0.2t upon 2 minus e raised to the power minus 0.2t. Okay. So you need to just put h is equals to 8 in order to find the corresponding value of t, and you need to show all of your steps, because solutions relying entirely on calculator technology are not acceptable. So you need to solve the equation and you need to show all of the steps which are supposed to be shown, which are required over here. So 8 is equals to 10 plus 3 times e raised to the power minus 0.2t divided by 2 minus e raised to the power minus 0.2t. Therefore, when 8 is multiplied with this whole expression, so this becomes 16 minus 8 e raised to the power minus 0.2t, and this is equals to 10 plus 3 e raised to the power minus 0.2t. And the terms which are related to e raised to the power minus 0.2t will be taken on one side, and the others which are not related to e raised to the power minus 0.2t will be taken on the other side. All right, as simple as that. So minus 8 e raised to the power minus 0.2t minus 3 e raised to the power minus 0.2t is equals to 10 minus 16. So minus 8 minus 3, this will become minus 11. So minus 11 multiplied by e raised to the power minus 0.2t is equals to 10 minus 6, which is supposed to be, 10 minus 16, not 6. अच्छा वो अभी दिख गया मुझे. 10 minus 16, which is minus 6. And as we can see that this minus sign and minus sign will be cancelled out. So e raised to the power minus 0.2t will be equals to 6 over 11. And now we need to find the value of t. And for that purpose, we need to make t the subject of the equation, and we need to introduce log on both sides. We need to introduce ln on both sides. So ln e raised to the power minus 0.2t is equals to ln 6 over 11. So minus 0.2t multiplied by ln e is equals to ln 6 over 11. And since ln e is itself equals to 1, so minus 0.2t is equals to 6 over 11. Okay, sorry, ln 6 over 11. I forgot ln, sorry for that. And t equals, and since we know the fact that ln 6 over 11, I mean the value of 6 over 11 is less than 1. So ln 6 over 11 will be a negative term, and this will be, the minus sign will be cancelled out by this minus sign. Okay, so t is equals to ln 6 over 11 divided by minus 0.2. And you will get a positive value over here. Ln 6 over 11 divided by minus 0.2, t equals 3.03, and t is basically the number of days after that monitoring has started. So therefore t is equals to 3.03 days. This is supposed to be your final answer. Now we have the last and final part where it is. Okay, I need to bring the picture again. Here it is. Part D says that, according to the model, the depth of the water in the tank will eventually fall to k meters. Eventually fall, which means that the maximum meters it falls up to a maximum k meters. State the value of the constant k. Now, what you actually need to do, as you know that when t was equal to 0, when you actually started the monitoring, the depth of the water was 13 meters. And when t is equal to 3.03 days, the depth of the water was 8 meters. Now, what we need to do, we need to find actually that the water in the tank will eventually fall to k meters. So what is the value of k? So this means that the number of days will approach towards infinity. Number of days will approach towards infinity, because we need to actually check what will happen to the depth of the water if we just leave we have so many days, infinite number of days after the monitoring actually started, so that the depth of the water will fall eventually to a certain k meters, a certain value of k, to a certain depth. Okay, so this means that t approaches infinity, the number of days are approaching towards infinite. So what we are going to see that when t approaches infinity, what happens to the value of h? So h basically approaches towards k meter. When t approaches infinity, h approaches towards k meter. H approaches towards k meter, the depth of the water eventually falls to k meters. We need to find the value of k over here. And as we can see that when h was made a subject, h is equals to 10 plus 3 e raised to the power minus 0.2t, and this is divided by 2 minus e raised to the power minus 0.2t. Okay, just wait for a second, it is coming on screen. So when t approaches towards a very large number, infinite number, so first of all, what we are going to see that in the expression, what is related with t? Actually, it is e raised to the power minus 0.2t. So when t approaches an infinite value, what we are going to check, what happens to the value of e raised to the power minus 0.2t. Okay. So when t approaches a very infinite value, a very huge number, so what will happen when exponential, I mean the exponential e, when e is raised to the very large power, let's say e is raised to the power 1825. So the calculator is giving us math error. All right. And and e is basically approaching towards a negative power. So e raised to the power, let's say minus 85. Okay. E is approaching towards, e is approaching to the power minus 85. As we can see that here we have minus 0.2 as well. Okay. So let's say e raised to the power minus 85. So e raised to the power minus 85 will give you 1.216 multiplied by 10 raised to the power minus 37, a very small value, such that the calculator is giving us in a standard form, and 1.216 multiplied by 10 raised to the power minus 37. So this means that when t approaches an infinite value, e raised to the power minus 0.2 t approaches towards 0. As simple as that. It becomes very small. So when t approaches an infinite value, what we are going to do, 10 plus 3 times 0, in place of e raised to the power minus 0.2t, we will just substitute 0. 10 plus 3 times 0 divided by 2 minus 0. So 10 over 2 is 5, and your final answer is supposed to be 5 meter. The value, your final answer is 5 meter. The value of k is equals to 5. H, basically the depth of the water will eventually fall to 5 meters. Okay, it cannot fall below that. As simple as that. So this was basically January 2021 question number 10.